We're going to be talking about the sum and difference identities. With that being said, the sum and difference identities mostly is based on 30 degrees, 45, or 60 degrees. So when we're talking about our unit circle, we're looking for a breakdown of this information. Actually, 30 / pi over 6, depending on which unit of measure you're in. So these are numbers you need to know. They're not bad. We'll talk about easy ways to remember what they are, because there is kind of a pattern to it. And with that being said, these are things you need to know in terms of the exact value. If you use your decimals, the decimals aren't going to help you in terms of our simplification looking at our sum and difference identities on that formula sheet. For instance, why this is important and why they're having you do this is later on in the future, or potentially in your college math classes, you are not allowed to use a calculator. So I wouldn't be allowed to type in what is the cosine of 105 degrees. I would be expected to use the sum and difference information in order to break this down. With that being said, 105 is actually the breakdown, so we're looking for breakdowns in terms of either 30, 60, 45, or 90, something of that nature. Cosine 105 is actually cosine of 60 plus 45. So here's how this is going to help us. We're going to be able to use that sum and difference formula of the cosine of alpha plus beta. It's about midway through your formula sheet, so that's what we're using there. With that being said, I'm going to use it now in terms of our actual numbers that we have. So I'd have the cosine of 60, cosine 45 minus sine 60, sine 45. So I'm now going to actually calculate what is the cosine of 60, cosine of 45, using our coordinates from back here, knowing that the sine of 30 is a half, or the cosine of 30 is square root 3 over 2. So I have a half times square root 3, square root 2 over 2, minus square root 3 over 2 times the square root of 2 over 2. Okay, got rid of my sines and cosines. Now I'm in exact values. I'm going to simplify this. I have the square root of 2 over 4 minus the square root of 6 over 4. I'm going to just combine that as one big fraction, and I'm done. That would be the exact value. So if you wouldn't be able to say, okay, this cosine of 105 is this as a decimal, and they want exact values, this is how you break it down using those sum and difference equations. Sometimes you'll be asked to go the reverse way and figure out what was the original degree measure. So if I were to have sine 45 cosine 15 minus cosine 45 sine of 15. So what was the original measure, angle measure? Okay, looking at this, looking at your sum and difference formulas, you're trying to figure out, okay, which one is the reverse of this? I have a sine and a cosine together, which means that it's going to be a sine function of some sort, whether it's a plus or a minus. I have a minus in between, so that really gives me that this is sine alpha minus beta. So alpha would be 45, beta would be 15. So the original measure we were looking for was sine 30. Okay, so that one's the reverse way. That one's a little bit easier because you're going the backwards way. You don't actually have to simplify an exact value. Sometimes you'll be asked using those sum and difference formulas to verify or prove, which we've been talking about. Lots of fun. Let's say I have tangent x minus 360 equals tangent x. So we are verifying that. Okay, well, looking at our tangent, we have an x minus 360, so we're going to be looking at our tangent alpha minus beta. So I will have tangent x minus tangent 360 over 1 plus tangent x tangent 360. Okay, so again, not touching the right side still. So I'm going to simplify this. Tangent 360 is going to be actually end up being 0, which makes this kind of easy for me now. Well, looking at that, it's minus 0. This tangent x times 0 cancels out, and you're left with tangent x equals tangent x. Check. So again, sometimes you'll be asked to verify it using those sum and difference formulas to simplify to something else that they want you to go to. So again, breaking down, your 30, 60, 45, any of those measures that are on the unit circle, and we'll talk about how you can easily find those different measures without actually looking at the unit circle, because there is a pattern to it, and it'll make your life easier. But all we're working with are those sum and difference formulas on our trig identity sheet.